Okay, for spreadsheet, Google Doc, how multi-concurrent collaborations are handled. Okay, maybe we can get to that in a minute. Gaurav, I'm not very sure if you have seen the latest edition, the latest chapter. This is. Do they have some?
Okay, I might not have seen. Okay.
Yeah. No, it's not your fault. I don't think we have even announced it as much as we could. But I'll just show you the Google Docs chapter. 1 second.
Yeah, that's really helpful if it is there.
Yes, there is a. It's a pretty decent chapter, if I may say so myself. Okay, so let's have a look at this. What is the thing? InterviewReady. High level design, yes. Yeah, design at collaborative editor like Google Docs. This will help. Currently, the quiz and the PDF summary is not yet added. In fact, the API docs and the capacity estimation also has to be added. But it's a complete chapter. In terms of videos, it's got everything that you need. So specifically, you asked for locking, event passing, three-way merge, synchronization. That's going to be here. I think concurrent writes with locks, but then this doesn't work out. So instead, you go for operational transform. So, but then we don't just talk about operational transform. We talk about a couple of more algorithms here. Then maybe I can give a rough overview of what operational transform does.
Yeah, basically, I mean, I heard about, like, I know about like these three conventional algorithms only. So yeah, just was interested, like, what exactly is used, in this system.
So you, like you mentioned, it's you're absolutely right. Conventional algorithms, one of them is locking. So amongst them, you have pessimistic and optimistic locking. The problem with this particular scenario is there's a lot of people all around the world, possibly offline, who are making changes. So when you make changes to the same document, if I open Google Docs here, Google Docs. Yeah, we are having a secret Santa, yes, amongst all YouTubers. Okay, so now I'm typing over here. If I share this link with you, you're going to be also typing over here. So let's have anyone with the link can edit. And you might have done this actually in a flight. So
yeah, it's like quite fast actually in Google Doc.
Yeah, the problem is if I'm typing something and you're typing something else, and you start going over here and you bold something, and somebody else comes over here and they make this part italic. This is very complex when it comes to any kind of locking, because you're locking on ranges, one, and two, there are so many things that could result in a lock. So this is not going to work. Instead, what you end up doing is you use a specific algorithm for text collaboration. So the standard algorithm for this is operational transform. Very involved, very complex, in my personal opinion. But I would say, like, this is like Paxos. You are not expected to know this, but knowing that the algorithm exists is useful. Okay. Operation transform. A rough overview is this. I'll just share the screenshot if you see over here. And the idea is two people are doing two different operations on the same document. You take two different versions of those documents, and eventually you're able to merge them together. So the algorithm specifies how you can merge things by giving an inverse operation. So delete one, inverse of delete one here is going to take you over here. And add E2 at position 2, you have to add a E. You can call this the inverse, is taking you to the same document. So a sequence of operations the same document. That's your, you want a consistent document. There is one algorithm, operational transform, the benefit is it's a centralized algorithm. So everybody sends to one person and one person makes the decision. There is another algorithm or another data structure which is getting very popular. Martin Kleppmann has actually done a lot of research on this. CRDT, which is conflict resolution replicated, I think. Yeah, replicated data types, conflict-free replicated data types. Yes. So this is a decentralized algorithm. I'm giving a very high-level overview, but it's a decentralized algorithm, meaning that if I type something and you type something, my changes will go to you. They'll make the local changes in your place, and your changes will come to me, and I will locally make the changes. While in Google Docs, it makes sense for all of our changes to go to the server. The server comes up with a final document that we get back. So operational transform is the one with the central server. If you have a distributed consensus algorithm, let's say, complicated conflict resolution, I never get CRTTs is what it is.
Yeah, but there can be scenarios, for example, like starvation kind of scenarios wherein, one person like is stuck, like it's keep on getting updates but yeah, its update are not getting, maybe due to network bandwidth.
It is possible, but you will have to imagine a person constantly typing. So, and also how many keystrokes are you going to make? There's a limit to the number of keystrokes. Even if you go very far ahead, the rest of the things will come back. If there is by the way, there is let's say Kafka. Do I have it in the bookmark? No. Okay. Kafka.
By the way, like, is this same algorithm, like, does it work for a spreadsheet as well, like Google spreadsheet?
Google spreadsheet, huh? I'm not sure about it, but if you think about Google spreadsheet, everything is in a cell.
Also, like, we can add, I think, I'm not sure, like, I haven't used a spreadsheet much, but I think we can add columns and all, right? A new row.
Yes.
If needed.
I'm not sure about spreadsheet. That's a good point, because it has cells, it has columns, it has rows. It's much more structured than the standard Google Docs. Can we do it using Google Docs, or would it be a bad idea?
I mean, I generally do think that it's maintained sort of like in form of nodes, like each cell value.
Yeah.
And
it makes
it's like whenever
have it that way, the way you're saying. But the problem is, what if somebody takes all of them together and bolds them all? So those are my concerns.
Yeah, that random access. Yeah, that is a bit, and it can have like endless number of columns, like if or rows, if you think that way, right? So
yeah, and
that access can be
inside a column. Let's say you and I are making the changes inside a cell. So what happens then? Do I block your changes? I don't think I will block your changes. Some sort of resolution has to happen. So maybe per cell you can do a operational transform. Maybe that, yeah.
But wouldn't it be like too complex, given that it's a just spreadsheet?
I mean, it is complex. It seems like you can lock things, but then offline mode won't work. Somebody is making a lot of changes, somebody else makes some changes.
Yeah, right. Yeah, other cells also we have to take care of. Yeah, right.
Sivaram has an interesting idea, just like Git. Unfortunately, Sivaram, problem with Git is that, if you have any conflicts, you do it yourself. You take the diff, you see the changes, you pick which one you want. So merge conflicts are actually resolved by the developers. Here you want an auto resolution. So some algorithm has to exist which will give you auto resolution. One thing which is pretty interesting in this is, I think, the Myers algorithm, which is used in Git, is something that can also be used when you're working with Google Docs. I think we have it. Sequence between two. Yeah, the longest common. So when you're looking for two diffs, Normally you don't want to take the entire doc and as a single version. So you just want the diff. So the diff, there are some ideas around it. Longest common subsequence is one. You can also use something called the Myers algorithm. Again, this is never going to be asked in an interview, but the good thing is, like, if you really want to dive deep into this is possible. Yeah, Git.
Is it based on LCS, longest common subsequence?
It's not based on LCS, but knowing LCS helps.
Okay.
So what ends up happening is LCS is a pretty good algorithm, not a problem. I think the people who came up with the guy who came up with Myers algorithm, or the person who was explaining this, was also the creator of BitTorrent. I think there's a protocol, so he wanted to see the differences, and I think that's the guy, who's explaining this. He explained it quite well. Many of the algorithms which work internally are unknown sometimes, unless you like really dive deep. So from the perspective of engineering, yeah, we can use this at a high level. But yeah, if you really want to go deep, this is also something that helps you understand. Does anybody here feel confident with Paxos? I always take that as an example, like, okay, there's a certain depth that you want to get into, but after that you don't. Like, Paxos is super popular, but still, because it's complicated, because it sometimes takes away from the application level problems that we have.
So, like, are we expected to know till mid-senior level, maybe, like, about?
I'm not expected to know even operational transform, how it works internally. I don't see, but okay, let me come to the point that most interviewers will be at. You are not expected to know what operational transform, how it works exactly. But if someone says, okay, let's try to develop the algorithm right here, right now, some sensible ideas should come in. How is this going to work? So if you have two concurrent versions of a document, how am I going to put them together? So you came up with the approaches of locking, and I think three-way synchronization is something you mentioned. Three-way merge. So these are good ideas, right? If an engineer is asked that, how do you think it works internally, and they come up with no ideas, that's a problem. Event passing. Okay, yeah. Event passing is technically what they are doing. Yes, they are saying add this, delete this, so on. Okay.
Yeah, I think event passing, like, you just send that update to everyone, and then I think, I'm not even sure.
Yeah, exactly. How's it being applied is a problem. But you're right. Event passing is what they're doing. Yeah.
In which one?
In operational transform, event passing is what.
Okay.
But event is creating new objects conceptually. But how is it being merged together? That is the algorithm. Okay. This is an interesting question. We can dig deeper into this. Guys, do check out this new chapter on Google Docs. It should be helpful. It's a different kind of a problem, so it's interesting to solve. Any plans for system design books or PDF materials? Vivek, we do have PDF materials for every chapter. This should help. Wait. No, this. Why doesn't this have? Yeah, you should be able to download this. If I download this. So we have it for every chapter. It doesn't have for live streaming, is it? There's an architecture diagram, there's capacity planning, but it doesn't have it for every PDF. How about this? Yeah, for most chapters we have it. I think only for one live streaming we don't have the PDF. Everything else you should be able to get a summary PDF. Okay, books, I haven't considered it yet. It's a pretty big thing. Then I have to keep InterviewReady on hold and start writing a book. Abhi is asking, hi Gaurav, I couldn't understand the chess game design. Let's open that up. What is the exact need for the separate connection service when the connections are stored in the DB separately? Because if we restart connection service for every update in every other service, then connection service also faces the same issue that we face in the gateway. Also, why do we need to restart connection service whenever there is a deployment in any other service? Okay, I should have explained this better. Let's go there. Request batching and connection related thundering. Okay, so also let me just open whiteboard. What do I exactly mean by why should we have a separate connection service, right? If you haven't checked out this chapter again on chess design, I would strongly recommend having a look. This again is a different kind of problem. It's a game server, turn-based game server that is being developed. So do check it out. Okay. Let me also share my screen here. Okay. Yes. Is my screen visible, guys? Anyone? Vivek, Shivaram, Abhi?
Yes, Gaurav, it is visible.
Look at this nice diagram over here. No, so chess design is a question. Basic idea. The basic question is this: that what I suggested in the chess design is you can have a gateway, and this gateway speaks to another service which does, let's say, a protocol translation. So this is, let's say, HTTP or whatever you like, and this is your internal protocol. Also, what this does is it stores the session data. Okay, now I said let's separate this out. Why? Why do we need to separate this out? Because after all, aren't we just adding another service to the critical path? This becomes an additional single point of failure with no meaning. The reason I suggested that is in a chess game, you actually have a lot of users connected to this gateway. Whenever there's a code change, let's say this is the application, the app makes frequent changes, not just in the code that it has, but also in the client that it provides to other services. So if you have many services speaking to this app, their clients need to be updated. So this app provides a client through which you can speak to this app. This is standard practice. Instead of you hitting the API of the app directly, you have a client provided by the app which you use to hit that service. It's also there on the gateway. Okay. There is one problem though. If the API has a breaking change, then all of these clients need to be updated and restarted. Okay, when you're making a client update, when you change the version of the library, you need to restart the service so that it reflects those changes. It is able to take those, able to hit those APIs. So restarting the services here is not very expensive. It's cheap. You can do a rolling restart. You can't, maybe because you have changed the API. But this is a loss. The loss is not that big because the people who have made connections from outside, your customers, are currently playing the game, their chess game. If the gateway restarts, everybody loses their connections. That's not good. Instead, you can make the gateway as dumb as possible and always keep these connections on. You never restart your gateway. You take the logic over here of the app and you move it here. Now your session service talks to this internal service. Your connections are always kept alive, and what you send over here to the session service is a raw string, which can be mapped in any way you like. Okay, when the client changes, that's okay. It takes the string and it behaves in a different way. It converts it to a different object. Okay, you didn't lose the connections that you had over here. That's the idea. So your users continue having a good experience. If you didn't do this, if you had if you restarted your gateway, let's say because you had some change in your client, the problem would be you would need to lose all of the connections. Everybody would want to connect back to you. That would result in a thundering herd. Everybody is trying to create a connection with you, and that would possibly overload the gateway or definitely put a big spike on the gateway, maybe increase latency. You may not be able to meet your SLAs. So this is one of the things that you can do to keep your connections alive. Okay. If you have any more doubts on this, Abhi, let me know.
Yeah, got it, Gaurav. But like small, maybe it sounds dumb. Like, why do we actually have to like? Let's say I'm just making a very minor code change in some service. Then should I actually have to let's say that doesn't affect any URL, the API URL or something. So even in that case, should I be restarting the connection service? No, right?
No, you won't need to also. But having said that, like the session service won't need a restart. If there are, so let me clarify. Firstly, for minor changes, this is not relevant. If the number of services are less, this is not very relevant. And if the number of breaking changes are low, then this is not very relevant. Okay. Now, in a large organization, the number of services keep going up. And the number of breaking changes, despite our best efforts, are there. So if you have, let's say, 10 teams working on 10 different parts of the service, like the profile service does not have any breaking change for a month, but the emailing service has a breaking change. The problem is all of this is concentrated, condensed into this person, the gateway. Many of these apps don't talk to each other, but the gateway talks to everybody because it has to convert the request into a request of that type. Like this person is having green, blue, red, every kind of service possible here. This person maybe only has green. This person maybe only has blue. So the idea is all of this is concentrated into the gateway. All of these breaking changes are concentrated into the gateway. So the probability of a breaking change keeps increasing, frequency keeps increasing. So this is, let's say, unavoidable. If your company is small, then the number of breaking changes will be less. But if your company is large, then the number of services keep going up. And so the gateway basically keeps losing connections. Maybe once a day, maybe once a week, but that's still a problem. And of course, I mean, if you have that kind of scale where the number of connections are difficult to recreate, or if you have that kind of an application where the number of connections have to be created quickly, then you don't want to restart your service. So places where this works is chat applications, game servers, and things which are real time or which require persistent connections. You won't need this, let's say, in Vimeo or even in Zoom. We are having this meet over here. We are using UDP. So there's no connection as such, except that over here I'm using RTMP. But that is just one guy, right? One connection. So if you break my connection, I'll recreate it. But if hundreds of connections or thousands of connections are there, then it makes sense.
Yeah, got it. So this connection service also acts as like a session service registry, right? Yeah.
Yes. So the connection service, if we make it as dumb as possible, that is the best idea. So it acts as a service registry if you let it. Take the service registry and put it out somewhere else. It acts as a load balancer if you ask it to. Maybe a randomized load balancer, then you don't need to do anything. But if you have a load balancing algorithm, pull that out, keep it somewhere else. Finally, what it acts as is apart from a reverse proxy, it also acts as a parser. So every request that comes in, it converts into the object that you want according to your client and sends it to your respective service. That also you remove. it just becomes a connection holder. So all of that logic is either moved here or into separate services. If it's if it's a startup, obviously this is way too much. This is overkill. But the idea is you don't want to lose any connections in some applications. Okay, that's a good question. So in Google Docs, changes are pushed to server and server pushes to every active window. So do only changes are pushed to each active window or whole doc is pushed? That's a good point, Vivek. Changes are pushed to an active window, yes, or pulled. We are not very sure. You can have a polling mechanism on every window. Do I have that open, that doc? I must have shared something. Yeah, this doc is open. Okay, this now let's say is either being polled by your open client, this browser, or it's being pushed. I think polling would make more sense. But okay, let's assume that somehow we are able to manage this connection. What was the original question? I'm sorry. So they're pushed or pulled into every active window. Do we send the entire document or do we send the diffs? I think we will be sending the diff, but it's a bit complicated. It's like you were at version 3, which is ABCD, and then you send this to Google Docs. Google Docs then said, oh, okay, but a person has just deleted the character D. So please consider ABC as your new document. Now, by the time you get this, you are at ABCDE. So this is version 5, this is version 4. Now, how do you reconcile? Right? What if one of the things you can do is you can just delete these 2 characters and say, I'm now reconciled at 4. Or you can take this 4 and apply the new changes that you had from 3. Okay. Which means you need some sort of client logic to help you do this. There are some problems that I can see here. One approach was, okay, fine. What if you don't apply these changes and you say that from ABCDE, this is the new version, I want to send it to Google Docs, but how does that help? So the way operational transform will solve this is if you have ABCD as your original doc and you say add E and the server says delete D. So this becomes ABC. This becomes ABCDE. Now you know that this is the new version. So what has to happen is there has to be some sort of merging together to ABCE. Okay. Now while this has happened and the server says, okay, ABCE is what we need to send. What if you deviate even further? What if you go A? And now, is anyone else also seeing the same problem?
I think the screens only support like 60 frames per second. So it's not like we can have a lot of changes every second.
Yeah.
In 1 second, there could be only 60 changes. So it's like not more than 60 edits can go in a second. So even if hundreds of people are using it, every 1 by 60 seconds, we need to update the screen.
Even if you update it, let's say 1 by 60, the number of times just talking to the Google server will be around once every 2 seconds. In that, you can have some changes. Do you just override this? Do you say, okay, ignore this, just take this as the new version? The loss is minimal. That is one approach, that the server just said this. So start here. This is your new starting point.
But what if the string was like too long? I mean, and like changes were in like, let's say, let's divide it into segments. So maybe there was one segment. I mean, I made change in like segment 1, and someone made change in like last segment, right?
Segment mein na, like that's also discussed in the chapter. If you do segments, there's a starting and ending segment. So now people come and they start adding stuff here, lots of stuff, and then DEF comes here. So it's no longer in your segment. If you start using indexes, the problem is there might be range updates, like make this area bold. So we have to use the entire doc.
If we break it into segments, that's like we are updating a wiki page or something. Over there, we take a lock at the time of writing.
Okay. Wiki page,
Right.
so I'm not sure. Multiple people, can we collaborate on a wiki page? I've never.
Yeah, so it's all like multiple people are writing and updating a wiki page or a Jira Confluence page. But
Yeah,
in Google Doc,
that
it's
may take some
real
sort of
time.
versioning, right?
At the time of writing, over there we take a lock, and then the merge conflict would come. But in Google Doc, it's more real time.
Google Doc is real time, and also the merge conflict is auto handled, let's say, by the server.
Yeah. So even before merging, it will automatically change your document. So at the time you are writing, it won't commit your write. Before committing, it will check if you are on the latest write.
Okay, that is wiki. Wiki is like, it's not a commercial product. That's why it's like, I guess, they are like, okay, fine. You made the changes, you figure out what the right changes you should keep. What are the right changes you should have? But Google Docs has this auto resolution thing. Now, how do you resolve changes that you have made on your client while the server saw your changes and then reconciled them and then sent you back this version? Overriding is one possibility. Or on the local client, you can have maybe some sort of smart logic which says, okay, this person just added an F.
So even on Google Doc, there's a limit of 100 people who can access a document at one particular point of time.
Yes.
So not more than 100 people could do this.
Yes.
So probably that is how they are managing the server power. So it's not like thousands of people are writing at the same time. It's less than 100, up to 100.
I think more than server power, it's more about granularity, right? Or the loss, like which Gaurav was talking about.
Yeah, it's a mix. The number of writers are reduced. Like if you see the Kafka document on exactly one's delivery, it's a Google Doc. But like thousands of people have it open. So then they say, listen, editor access is reduced. So that's interesting. But yes, the original problem of, if the frequency of updates are low, then you could lose up to 2 or 5 seconds of work, which I guess is fine.
Like I was just thinking one scenario. So let's say like some update happened and the Google Doc version is like at maybe some later point, like version 5, let's say. I mean some earlier version, right? Yeah. And user was updating this doc while offline, right? Yeah. And made some significant changes, and then like he came online, right? He or she came online.
Yeah, you're right.
So in that case, like what happens?
You made a huge number of changes here.
But offline.
Yeah, offline. So one of the things you should do immediately is go and talk to the server and say, listen, I have made these changes. The server will say, okay, my current version is this. It in fact won't even tell you my current version. It will just say, all right, give me your changes. I'll take my changes and your changes, and I'll come to a common point. So if I have, let's say, A, and you did all of this stuff, so I'm going to give you this new thing, which is AEF. And now take this. So you can be blocked on the server. Maybe you don't allow edits for a few seconds. That's not a great user experience, but okay. Or maybe you allow edits to go ahead, but then you delete them once you get AEF. That wouldn't make sense. the offline problem is not that big an issue here, because when you're offline, the moment you come off online, you talk to the Google server and ask them that reconcile, find what is the final state and give me the final state. I'll keep it in my local.
Okay, so thinking about like, I mean, how generally merge works. So if there's no merge conflict, then I think seems good. Like, but what if like there is a merge conflict and like it's not?
If there is a merge conflict in 3 seconds, utna bhi kuch nahi hua hai ki, you can't write it again. That will be a product decision that I would make.
Okay.
Because 3 seconds mein aisa kya hi likh dega wo, right?
और अगर no, not talking about 3 seconds. Basically, जो offline mode पे उसने जितना भी
like you have already sent this request and you are now telling the server that figure out what the final state should be and tell me. I don't want to lose these changes. Now, while you sent that request, in between you did more changes. This is the loss that we're talking about.
Yeah. I mean, yeah, I think that can be.
Ideally, like you said, if there is no merge conflict, why should we lose those changes? Let the person keep typing even then. But if there is a merge conflict, I think the client has to be smart enough that, yeah, I see a merge conflict, fine, I just pick this version. If there is no merge conflict, I will pick this version. I will get this new document without the merge conflict and again send it to the server saying that figure out what's the new version and I'll get the new version here. And meanwhile, I can continue again changing.
I think merge conflict are bound to happen.
It could.
If it's a file where you are having multiple files, then merge conflict won't be there because you are touching different files. Here, everyone is touching the same file. So
yeah, interesting point. But the merge conflict is impossible on the server side. The server handles every single possible operation that it offers. For example, bold from a region to region. Every single operation, deletion, addition, every single operation can be handled by the server. That's handled by the algorithm of operational transform.
Okay.
So the server will never have a merge conflict. The client could have a merge conflict with what has come from the server.
Yeah.
That is our assumption. It could also be smart about it. It could, I mean, operational transform is being done on the server. It could it locally do the operational transform again, then that would solve everything. If the client also, is smart about it and can handle every single merge conflict, then everything is resolved. But yeah, I mean, in a practical sense, I would say, okay, fine. Whatever has come from the server, if there's a 2-second delay or something like that, just ignore it, go ahead. There are a couple of more things which are complex. Like, for example, you're offline on your phone and you're offline on your computer. Now, and you're working on the same document. You send the request from your computer to the server, you connected. You got the newly formed document. Now, on your mobile, you kept typing. You type like this. So now you connect to the internet on your mobile also. What happens now? That's an interesting question. Because you basically have 2 devices which are offline, have worked a lot on the same document. It's come from the same user also. This was the original. Now what do you do? Server, again, the algorithm, you'll never have a problem merging this with what was there on the server. That's not a problem. Okay, from here, yeah. Now you try to connect here, Yeah, you'll never have a problem with the server. That's important to note. But yeah.
I think one small. So
is this making sense?
Yeah. Gaurav, can you hear me?
Yes.
I think some of us have kind of a request. If there is any question page, is that something which can be shared again?
Yes. The
chat.
So question pages, or do you have a question which you want to ask on the chat?
No, both together. So one was the request from some of the users, including me, to just share if there is any question page. That's first part of the question. No.
There is one over here, which is Slido. Let me just Today is 19th December.
Hi, Gaurav.
Yeah, hi.
Like I had one question that I mean, let's say we are like kind of syncing the Google Doc with like let's say every 60 seconds. Okay.
Mhm.
So let's say there are 5 users, and I mean for like kind of merging thing. Let's say we are using the versioning system.
Mhm.
So for like every change, every 60 seconds, there is version upgrade in every user's active users. You could say active users model.
Okay.
And I mean, let's say one user is offline, so he will be left behind in the version upgrade. Let's say there is in the server there is a current version is 20, and for the offline users he made some changes, and his last version is was 4. So how will the like server will manage the changes? Like has it been merged or not? Like how will the server decide that these changes are merged or not?
So let me draw that out because it was a little involved. And sorry, I also was looking at the questions page. Guys, you can post it on the link that I've just shared. Harish, was that you who was speaking?
So I mean, how will the server decide that these changes are merged or not? Like,
Which ones? Could you take that example again?
I mean, let's say let's say there is versioning system. Okay. I
Okay.
mean, we are using the versioning system,
Okay.
and for every like in the server there is has been 20 version. Like the current version is 20th for the doc,
Okay.
and I did some offline changes, and my last version was 4,
Okay.
and there is lots of changes coming. So like how those changes are like get to the server, and how the server decide that these changes are merged or not.
Okay. So you were at version 4, you moved to version 50. Here you had no merge conflict, obviously, because the client kept taking the changes that you were typing. You were
Right.
on a flight or you went on a vacation, you came back,
Right.
now you are connected again. So the server, how does it merge these changes is the question, or how does it know that how to take care of those changes?
Yes, I mean, how does it take care of the request, like incoming request, like how to like these changes are merged or not?
Okay. How does it know whether these changes are merged or not? So
Yeah.
what the server will be doing is there will be a version number. Does it even need a version number is the question.
Like we will send all the changes in the payload. I mean, there can be a lot of data in the payload in that case.
Why are we sending from 4 to 20? For the server, it's like one commit, right?
So let's say there are 50 commits that you have made, and the world have made around 20 commits. So let us put this at 0. So these are 50 personal commits, 20 group commits, and now they have to merge into, let's say, 70. Okay. So
it's like how Git works, right?
it is.
Right.
So let's say you have 50 commits, right? So f of 1, this is operation 1, with let's say G1, this is group operation 1. This will give you a particular answer. This is exactly how the operation transform works. Every operation can be not G1 actually, with the doc. So a document version, when you perform an operation on it, gives you a particular result. Okay, like that you do f of 2 with this result, let's say, and you can keep doing this till you get the final result.
So we like make 50 requests then for every changes.
Yes. You can optimize on it. There are ways that you can condense operations into one. There are ways in which basically what's happening is you're drifting away. You're drifting away and you're going away from this lattice. And these people are also drifting away from you. Eventually, you invert the operations you have done. So over here, you take these operations and you see how do you map this operation to your current state. So the algorithm tells you how to do that. This operation in the current state would, let's say you added B here. But in the current state, and at position 2, But in the current state, the B has to be added at position 13. Okay, maybe more characters got added because you did all this stuff. So each operation is mapped. And then finally, you have this state here. That is the final state. So your client gets this, and your server also starts mapping. It takes this and maps it to an operation over here.
Okay.
Like I said, you might have made some changes because of which some additions, deletions, so the position might change. Maybe it is no longer, the character does not exist. So, but the important part is every operation can be described as a function. I mean, is basically you doing an operation on a document, on a version of the document. This version is here. And then it keeps going in. Eventually, you'll come to this. And both server and client are now having the same version.
So I think, like you said, that we can do some compression on the client side. So I mean, that can be useful. Like let's say a user makes lots of changes and then rollbacks them. So I mean, that will make 2 commits and they will be useless kind of in the final merging.
So maybe you added something and you press backspace.
Yeah. So those kind of changes will be useless for the like final merging. So we can kind of merge them. So yeah, in that case, that makes sense for the client side compression.
So, we can make an assumption here that common, let's say, commits like that are then defined in the function itself. Like if you're adding 3 characters together, yeah, sure. The algorithm can be optimized that way. You don't need to say, if only 1 character is added, then I do this. And if 5 characters are added, then I'll do 1 character, 1 character, 1 character. I'll take all 5 and put them together. Makes the algorithm more complex, of course. But for optimizing, yeah, you can do that.
Or like we can do like something like for every deletion, we do the merges with the previous branches. So
ideally what you would like is that these 50 commits convert to 1 commit. And those number of commits also convert to 1 commit. So then you are highly optimized. Nothing is happening. You're moving very less. Number of operations being done on server and the wait time for the client is lesser.
Right.
Yeah, but yeah.
Okay, got it. Thank you, Gaurav.
Google Docs can actually afford to do this. Confluent can afford to do this. One of the interesting things is if you look at many apps which are counters, they just count how many likes have happened. And if they're distributed or they're decentralized, then you can use CRDP. Okay, this is again the same concept. Every single operation is defined, predefined. If you do this on this document, this will happen. You do this on that document, this will happen. Like it's not that complex. Also, you can think of if +1 comes to any number, then the eventual number has to be num +1. It's that simple. You just have to define the functions. But there may be like a simple counter is easy to do. If you have something like Google Docs with the bold, italic, highlighting, that becomes complex. Another thing which I think I've discussed in the chapter is what if you have to comment on something. So you have a doc. It has all this text, right? And you want to comment from here to here. What do you do now? What if someone goes and adds something to that? So have a look at the chapter. I think it will bring a lot of clarity. So Vivek, that's an interesting question. Gaurav has a question. DB as a queue is considered an anti-pattern, but for exactly once delivery semantics, isn't it better to use DB as a queue? Okay. Exactly once delivery. So how would you go about doing that? You don't necessarily need a DB. You need some sort of transaction on your in your system. So
like an SQS queue for it FIFO, AWS SQS queue with FIFO should serve the purpose.
Yes. So internally, how these messaging queues, let's say.
But for FIFO, like it is, I think at least once delivery, right?
At least
Exactly.
once. Yeah. Okay.
As far as I know.
No, that standard queue is at least once. FIFO, the first in, first out is exactly once.
I think one is like at most once. Neither one provides exactly once.
No,
I might be
FIFO,
confusing, like, but I think one is at least once and one is at most once.
I can recheck on that, but as much as I know, AWS FIFO queue is exactly once deliverable. That, however, the standard queues is at least.
Yeah, let me share the doc in that chat.
I can check and get back on it probably. Probably maybe you're right. I have to relook.
Even I'm not sure exactly how with an external system you can do exactly once, but
because I have seen I mean scenarios like in like whichever organization I worked on, and like they use DB as exactly once.
So
I
to
mean,
do exactly once, you have to do like two operations. One is like at least once, so that the system keeps sending the request, and then you have to make the request idempotent, so that you can get a confirmation even
if the
on a
request is
subsequent
idempotent, I mean it's at most once, right?
No,
not necessarily.
I mean you can follow at most once if the request is idempotent.
no. I mean the request is idempotent, so it keeps coming.
Right, Shreyas is actually right over here. Shreyas, do you want to? Sorry, I cut you off in between. Yeah.
Yeah, what I was saying is once you make sure that the request keeps coming, that is at least once. So you make a system that keeps sending the request again and again. And then if you make these requests idempotent, even if the first request didn't go through or did go through, you didn't get a response, in the second or the subsequent request, you would anyways get the response as success. So that makes the system exactly once. And this doesn't have to do with any system. You can make any of these possible with like any. I think most of these queues are configurable here.
Right. So if the request fails, you don't send back a response. You try to send back a response, and maybe you said I failed. Over here, it succeeded, but there was a timeout because of which the acknowledgement never went through, or before it went through, you got another request with the same ID. Now the receiver says that, oh, I got the request earlier with this ID and I successfully handled it, so it's okay. Like for example, if especially you're making a transaction, some money transaction, so you give a ID to that request. Sometimes you can also do it with user ID. Like this user can only do it once in their life, but it's just a variation of the transaction ID. Okay, that's one way to do it. Another way that you can do this, like if you're doing this cross system, is to actually use transactions. So you have a DB which is connected with Kafka or some messaging queue, and you have to send it only once, exactly once. So one thing you can do is you can use transaction semantics. Okay, a transaction, you are guaranteed, you can roll back a transaction, right? So if it doesn't work, it rolls it back. Once it works, it's done. You get the acknowledgement also. So that's another way to go for exactly once. You can have a look at how Kafka does exactly once. Semantics. It's
also, we need to do the same thing at consumer side as well, right?
Yes, that's what I said. Like if there's an external system which is needing exactly once delivery, it either gets Kafka's client, which does the exact ones for it. Basically, I think there will be some sort of idempotency only. Again, same idea that Shreyas had. I'm sorry if I got Shreyas, that was you, right?
Yeah.
Yeah. So the same idea. I think most likely this is what's going to be done. So you'll need a client, a Kafka client or a SES client on your system, which helps you do this. Or you write the client yourself, like basically you do it yourself. That must be it. Yeah, that must be it. Yeah.
Okay.
Or you have a cross system transaction. Like if you know about 2P, two-phase locking. At first, everyone says, okay, we are doing this. We are starting the transaction, and then everybody commits and everyone goes ahead. For that, you can have a look at.
What is the cost of like having this transaction?
Expensive, yes, to put it mildly. The cost of transaction, you mean
performance-wise, right?
Yeah, of course.
connection points and all that.
Transaction in general, it is expensive.
Hmm.
Paxos is one of the ways that you get distributed consensus. So Paxos is much cheaper because the majority agrees with you. But if you want every single server to agree with you, it is expensive.
Gaurav, maybe you can make a video on Byzantine failure. I was reading about it and I found that really interesting.
Yeah, it's interesting, but where did you come across it?
I was just going and I went through it.
So Byzantine failure is a very interesting problem, which you have when systems that you either do not trust or, it's not even that they are doing it maliciously, by mistake ho gaya, like code was bad or something. So in that, you need at least 2/3 of the servers to be trustable. Like in Quorum, half of the servers have to agree on something. In Byzantine, 2/3 of the servers have to agree on something. And the ideas are a bit complex because you can't trust every server that you get. Like you get a response, you don't want, like, okay, like in Bitcoin. If someone says, yeah, I have all the Bitcoins in the world, other people have to agree on it. At least 2/3 of the system has to agree. So
do we have any like lecture? I mean, any like this
not on Byzantine, because you will not
like on security.
On security, we have very basic security explained here on the emailing service.
Maybe like something like, for example, zero trust principle, or like,
okay, that's a little.
Those not.
Yeah, I haven't actually looked at the security aspect much, although at InterviewReady it became a real thing, and so I do know a little bit about security now. But on the system design aspect, we haven't touched upon in any of the chapters in terms of how do you make it a secure system.
Yeah, is it like on less focus generally, like in interviews and all?
In interviews, in the job, like most jobs, you're not really in a situation where you have to ensure random actors are coming and getting access to your system. The assumption is that you have a gateway which handles all of external communications. The internal communications are being handled by the gateway, so it's keeping you safe from the rest of the world. It's rate limiting for you. It's making sure that only, no bots are connected with you. Amazon actually gives you something called...
You're talking WAF?
Yeah. Okay. So this is like a service. Web application firewall, it identifies whether it's a bot or not. We actually had an issue that we were pinging our server and checking if it's alive every 10 seconds. So Amazon identified rightly that it's a bot. So then we started getting CloudWatch alert errors in the night. So, but yes, there are services which actually give you this protection. So you're insulated. But having said that, yes, if you are building a system in-house, you will need some idea of how to handle these problems. Apart from denial of service, though, for a person to enter your system is a bit of a challenge, unless you, like, where are you storing your passwords becomes a thing that you have to remember. Do you have a virtual private network through which you're connecting to your database? Those are the bigger challenges. Like, social engineering is a bigger challenge than actually breaking a system. Making a very simple system which is locked is easy. But if someone is able to, when they leave your organization, what if they take their passwords and go? That's a bit of an issue. So no wonder companies pay a lot for SSO, because they don't have to take care of all of this headache that this account has access to my thing. Like, if it's under InterviewReady.io, remove the email address, the person has no access. So, okay, yeah, that's one thing that we can do.
The question comes up is, at what point of time we remove that email address? Immediately when he leaves the company, or would it take time?
So if you have SSO, single sign-on, then basically you are handling the authentication to some extent. So if if they try to log into AWS and then AWS says, oh, you are an interview ready person, right? Let me talk to InterviewReady server and see if you exist. So InterviewReady server says, no, this person has been removed from the organization. Oh, okay.